SpaceX finally revealed what they've been hiding. These aren't just bigger grid fins. They're 5-ton monsters with a secret that changes everything about rocket landing. For months, engineers spotted weird asymmetrical patterns on Booster 18. Now we know why. These waffle-shaped beasts have hidden features that double aerodynamic efficiency in ways no one expected. But here's the bombshell SpaceX just dropped. There's something built into these fins that makes Mechazilla catches 10 times easier. What is it? Let's dive right in. Remember those pointed tips I mentioned? They're not just aerodynamic features. They're precision-engineered docking mechanisms that must align with Mechazilla's arms while falling at hundreds of miles per hour. Miss by even 6 inches, and you get a $100 million firework instead of a successful landing. But that's not the real secret SpaceX has been hiding. Look at this comparison image. The old grid fins from Super Heavy version 2 measured 4.9 by 2.4 meters, about 11 square meters total. These new monsters? We're talking 20 to 25 square meters. That's like strapping 2 entire rooms to each side of your rocket. The weight penalty is crushing. Each fin now weighs 5 tons. That's 20 times heavier than a Falcon 9 fin. Multiply that by 3 fins, and you're carrying 15 tons of dead weight. For context, that's like launching 3 cars into space just for landing control. So why would SpaceX willingly add this massive weight penalty? The answer will shock you. Here's what no rocket company has ever attempted before. SpaceX is trying to land a 400-foot skyscraper that's been superheated to plasma temperatures while traveling at thousands of miles per hour. The forces involved would tear apart any normal control surface in seconds. Those waffle pattern ridges? They're not decoration. Each ridge is a reinforcement rib designed to spread crushing aerodynamic loads across the entire fin structure. When hypersonic air hits these fins during re-entry, the pressure is so intense it could crush a car. These ridges distribute that force like a spider web, ensuring no single point gets overwhelmed. But even that engineering marvel isn't the breakthrough. The real secret is hidden in plain sight. Every rocket engineer on Earth knows one rule. Symmetry equals stability. 4 fins arranged at perfect 90-degree intervals. It's been the standard since rockets were invented. SpaceX just threw that rule in the trash. Their new design? 3 fins positioned asymmetrically at 90 degrees, and 180 degrees. It looks wrong. It feels wrong. According to traditional physics, it shouldn't work. But somehow, SpaceX made it work better than the old system. How is this even possible? The secret lies in coordinated control. Instead of each fin handling one axis of movement, all 3 fins work together like a synchronized orchestra. When the rocket needs to pitch up, 2 fins move in perfect harmony, while the third provides counterbalance. It's like having 3 people carry a piano. If they coordinate perfectly, it's actually easier than 4 people bumping into each other. But there's a darker reason SpaceX made this change, a reason they don't want their competitors to know. Each 5-ton fin is a massive liability. At 4 fins, you're hauling 20 tons of control surfaces, weight that could be used for payload, fuel, or life support systems. In the rocket business, every pound matters. Every ounce counts. By dropping to 3 fins, SpaceX saves 1 entire ton. That might not sound like much, but consider this. That saved weight means higher payload capacity, more fuel efficiency, and less stress on the landing tower. When you're planning 1,000 launches per year, that 1 ton per flight adds up to 1,000 tons annually of extra capability. But weight savings isn't the only advantage. There's something else SpaceX discovered that changes everything. Remember Flight 4's dramatic flap failure? Plasma eating through the rocket's structure like a blowtorch through butter? SpaceX found a brilliant fix, but it required moving the entire grid fin system. They dropped the fins 1 meter lower on the rocket. Why? Because now the fin control mechanisms sit inside the booster's main fuel tank, surrounded by liquid methane at minus 259 degrees Fahrenheit. It's like having built-in air conditioning for the most critical components. Meanwhile, they're protected from engine blasts during hot staging. No more melted actuators, no more warped control systems. Just ice-cold precision when you need it most. But the most shocking secret isn't about the engineering. It's about the materials. While competitors chase expensive titanium and exotic alloys, SpaceX made a counterintuitive choice. 304 stainless steel, the cheap option for the world's most advanced rocket. Why? The math is staggering. Titanium costs 15 to 20 times more than stainless steel. A single set of titanium fins would cost $150,000 to $200,000. Stainless steel? $10,000. With Musk's goal of 1,000 Starships per year, that's 3,000 fins annually. Using stainless instead of titanium saves $420 to $570 million every single year. That's enough money to fund an entire space program. But there's a hidden advantage that makes stainless steel superior for this application. Grade 301 stainless steel maintains its strength up to 1,550 degrees Fahrenheit. Grade 5 titanium starts failing at just 625 degrees. When you're dealing with reentry plasma, you want the material that shrugs off extreme heat. Plus, stainless steel can be rapidly welded for mass production. No complex forging, no specialized facilities. Just fast, scalable manufacturing that can meet insane production targets. But the real breakthrough isn't visible from the outside. Look at how SpaceX manufactures these fins. Those wave-shaped ridges aren't just cut into flat plates. Each fin is 3D printed as a single piece with integrated cooling channels, structural reinforcements, and mounting points all built in. Traditional manufacturing would require dozens of separate parts welded together. SpaceX does it in one continuous process. Fewer joints means fewer failure points. Fewer failure points means higher reliability. Higher reliability means you don't lose $100 million rockets. But even this isn't the most important secret SpaceX has been hiding. Those catch points aren't just grab handles. They're precision-engineered docking ports with tolerances measured in millimeters. When a 400-foot rocket is falling from space, those points must align perfectly with Mechazilla's arms. Each catch point is designed like a large pin with a precision hole. When Mechazilla's arms close, they create a mechanical lock stronger than any landing legs could provide. But here's the genius part. These pins are adjustable in length. Why does that matter? SpaceX has 2 different launch towers with different catching systems. By tweaking the pin length, Super Heavy can land on either tower. It's like having a universal adapter for rocket recovery. This seemingly small detail has massive implications for launch cadence and operational flexibility. Just days after SpaceX revealed these revolutionary fins, something unprecedented happened. President Trump signed an executive order specifically targeting the regulations that have been choking SpaceX launches. The order directs the FAA to eliminate or expedite environmental reviews for commercial space launches. It cuts bureaucratic redundancy at SpaceX's primary facilities. The timing is impossible to ignore. Environmental groups are calling it reckless favoritism. Competitors are crying unfair advantage. But the regulatory barriers that have delayed SpaceX for months are suddenly disappearing. This isn't just about bigger fins anymore. It's about reshaping the entire aerospace industry around one company's revolutionary approach. And those massive grid fins? They're just the opening move in a much bigger game. The question isn't whether these fins will work. SpaceX has already proven they can catch rockets out of midair. The question is whether the rest of the world can catch up to what SpaceX is building. And based on what we've seen, that gap is only getting wider. So there you have it. SpaceX's massive grid fin secret isn't just about bigger control surfaces. It's about revolutionizing rocket recovery, slashing production costs by hundreds of millions, and breaking every traditional rule of aerospace engineering. These 5-ton waffle monsters represent something much bigger than landing fins. They're proof that SpaceX operates by completely different principles than the rest of the industry. While competitors argue about incremental improvements, SpaceX rewrites the entire playbook. But here's what keeps me up at night. If SpaceX can achieve this level of innovation with something as simple as landing fins, what are they working on next that we haven't seen yet? Raptor 4 engines? Block 3 Starships? Mars landing systems? The grid fins were just the beginning. The real question is whether any other company can match this pace of radical innovation. Because at this rate, SpaceX isn't just leading the space race, they're creating an entirely different game. What do you think? Are these grid fins the key to making Mars colonization possible, or is SpaceX moving too fast for their own good? Let me know in the comments below. SpaceX's Block 4 just revealed 5 absolutely insane upgrades that shocked the entire space industry. We're talking 81-meter height, 9,240 tons of thrust, and a fuel transfer tube as massive as Falcon 9. But those are just the obvious ones. The hidden upgrades are even crazier, including a complete engine redesign and something nobody saw coming. Which upgrade is the most mind-blowing? Let's dive right in. Here's the thing nobody expected. When SpaceX first announced Block 4, most experts thought they'd just tweak a few components. Instead, Elon Musk dropped a bombshell that sent shockwaves through the entire aerospace industry. Block 4 isn't just taller, it's a complete transformation. We're talking about growing from 71 meters to 81 meters. That's like taking a 20-story building and adding 3 more floors on top. But here's where it gets insane. Those extra 10 meters aren't just for show. The math is mind-bending. Current Block 2 holds 3,400 tons of propellant. Imagine 2,267 cars worth of fuel stuffed into one rocket. Block 4? It packs 4,148 tons. That's a 22% increase in fuel capacity, which translates to something revolutionary. By the time any rocket reaches stage separation at 90 kilometers up, it's running on fumes. Just 10 to 15% fuel left. It's like driving cross-country with your gas light already on. But Block 4's massive fuel increase means the booster can actually fly back home and land safely instead of becoming expensive ocean fireworks. But why did this size increase shock everyone so much? The answer lies in what SpaceX was secretly planning. Remember when NASA's space shuttle was the pinnacle of human engineering? 5 engines producing 3,118 tons of thrust, capable of carrying International Space Station components to orbit. That was the absolute limit of what seemed possible. SpaceX looked at that record and completely obliterated it. Block 4 uses 33 Raptor 3 engines, each pumping out 280 tons of thrust. The total? 9,240 tons of liftoff power. We're talking about nearly 3 times more powerful than the legendary space shuttle that built the ISS. But here's the twist that left aerospace engineers scratching their heads. Raptor 3 actually burns more fuel, 801.51 kilograms per second, compared to Raptor 2's 663.88 kilograms per second. Most people would think that's terrible efficiency, right? Dead wrong. Despite burning 21.7% more fuel, Raptor 3 is actually 1% more efficient per kilon of thrust produced. How is that even possible? SpaceX completely redesigned the engine from the ground up, removing fragile components and cutting auxiliary mass by 87%. The visual transformation is shocking. Raptor 1 looked like a flying spaghetti monster, a bird's nest of cables and protective systems. Raptor 3? It's so sleek that Tory Bruno, CEO of United Launch Alliance, thought SpaceX was trying to fool everyone with fake pictures. But the most shocking revelation came when SpaceX revealed what this engine upgrade actually enables. 2 weeks ago, SpaceX casually mentioned something that made rocket engineers around the world stop dead in their tracks. Buried in a technical update was a detail most people missed: a giant transfer tube nearly the size of an entire Falcon 9 booster stage. This isn't just plumbing. This tube solves a problem that's been killing rockets for decades. Here's the deadly scenario. When a rocket flips during landing, fuel sloshes around like water in a bottle. You're shaking violently. At the worst possible moment, during engine restart for landing, the fuel gets cut off from the engines. That's exactly what killed Booster 14 during Flight 9. The rocket attempted a steep landing approach. The fuel flow got disrupted and boom, rapid unscheduled disassembly. SpaceX's solution? This massive transfer tube channels subcooled methane directly from the main tank to all 33 engines, maintaining fuel flow even when the rocket is doing acrobatics in the sky. But here's what's truly insane. This tube enables simultaneous engine starts, faster flip maneuvers, and something SpaceX hasn't publicly announced yet, the ability to land on drone ships in the middle of the ocean. Why would they need ocean landings when they have the perfectly good Mechazilla tower? The answer will shock you. Remember the hot staging ring from earlier flights? That massive metal component that helps separate the booster from the upper stage? SpaceX literally had to throw it away after every flight, hiring ships to fish these million-dollar pieces out of the ocean. Block 4 just made that entire problem vanish. Instead of a detachable ring that gets discarded, the new design is fully integrated into the booster itself. No more ocean fishing expeditions, no more wasted hardware, no more assembly nightmares. But the engineering behind this is revolutionary. The integrated system provides dramatically more room for exhaust gases to escape, manages heat and pressure better, and offers superior protection to critical components like the grid fins. You can actually see the Raptor 3 engines clearly through this redesigned structure. This isn't just about saving money, though it saves millions per flight. It's about making rocket reuse so smooth that SpaceX can achieve their ultimate goal: launching rockets like airlines schedule flights. But the fifth upgrade is where things get really weird. This is where SpaceX completely shattered conventional aerospace wisdom. For decades, everyone knew you needed 4 grid fins for proper aerodynamic control. Basic symmetry, right? 4 fins, evenly spaced, perfectly balanced. SpaceX looked at 60 years of rocket science and said, we're doing it differently. Block 4 uses just 3 grid fins, arranged in a completely asymmetrical 90 to 180 degree layout. When aerospace engineers first saw this design, many thought it was a mistake. How can you control a 5,000-ton rocket with uneven fins? Here's the mind-bending truth. Breaking symmetry actually improves control. The asymmetrical setup creates intentional mass imbalance that enhances flip maneuvers and controlled braking during descent. Plus, fewer fins means less mass. And when you're building hundreds of rockets per year, saving 1 fin per vehicle creates massive production gains. The repositioning is equally genius. Moving the fins 80